Hey guys, what's up? Today we're looking at doing an indefinite integral of a function here, and the function we have is the cube root of x plus 1 over the cube root of x. So some things we're going to need to do this integral are, first of all, we're going to do some algebra, but once we do some algebra, we're going to need to know the power law for integrals. So recall the power law for integrals. So power law says that the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c if n is not equal to negative 1. Basically, n can be any real number except negative 1, and this is going to be true. So this power law is going to be true for any n that's not negative 1. So what we're going to do is we're going to take our integral and we're going to rewrite it in terms of rational exponents. So this is going to be x to the 1/3 plus x to the negative 1/3 dx. Right? Because 1 over cube root of x is actually just x to the negative 1/3. Right, the cube root of x is x to the 1/3. It's in the denominator, so if we move it to the numerator, it becomes negative 1/3 right there. So now we just apply the fact that we can break this indefinite integral up into x to the 1/3 dx. So integral of x to the 1/3 dx plus integral x to the negative 1/3 dx. All right, so now we apply the power law in each case. So this is going to be x to the 1 plus 1/3, or I should say 1/3 plus 1, divided by 1/3 plus 1, plus x to the negative 1/3, x to the negative 1/3 plus 1 over negative 1/3 plus 1 plus c. And now if your teacher is really lenient, they'll accept that answer right there, but probably what they want you to do is go ahead and simplify that a little bit. So that exponent 1/3 plus 1, let's just kind of work that out over here, I guess, off to the side. So 1/3 plus 1 will be equal to 1/3 plus 3 over 3, which would be 4/3. So the exponent on the first one is going to be x to the 4/3 divided by 4/3 plus, and then we have negative 1/3 plus 1. So negative 1/3 plus 1. Well, kind of easy to see. We can see that that's just going to be 2/3. Basically, if we just take 1/3 away from 1, we get 2/3. So that's going to be x to the 2/3 divided by 2/3 plus c. And basically, when we divide by a fraction, we multiply by the reciprocal, and we can say that this is going to be 3/4 x to the 4/3 plus 3/2 x to the 2/3 plus c. And that's our answer right there. So notice, and I try to emphasize this all the time, but whenever you have a rational exponent, the exponent that you end up after your integration, you're going to multiply out front by the reciprocal of that exponent. So you're going to have to multiply the front by the reciprocal of the exponent that you get after you add 1. So that's just something that happens when you have these rational exponents, and just keep that in mind. So that's how we do it.